The next part of our configuration will involve setting up the different load balancing methods. Now, we get to the heart of what provides the load balancing mechanism. Simply put, load balancing is the process which allows the big IP to distribute client requests among a group of servers. But there are many different methods for how that can be done. First off, there are two types of load balancing. There is static and there is dynamic load balancing. Static load balancing doesn't consider the server's performance or the total connections for its decision. Where dynamic load balancing, it does consider the performance and connections to each server in a pool for its ultimate decision. Now, based on the type, there are different methods that can be set up. For static load balancing, there is round robin and there is ratio methods. For dynamic load balancing, there is least connections, fastest to ratio-based methods like observed and predictive. Round robin is the default if nothing is configured and sometimes the most common, but it is not recommended. For round robin, each client request is distributed evenly among a group of servers in a pool. So for example, if we have 3 client requests that reaches the big IP, then one of those requests will be sent to one server and then the next one go to another server and the other request will go to a different server. So everything is load balanced evenly among all of these servers in this pool. So as you can tell that using this method, it does not consider the performance or connections to a server. And therefore, there is no additional selection for round robin, whether it is based on the node or the pool member. The other methods can be load balanced based on the node or the pool member. Now, load balancing based on the node will use only the IP address and connections to that IP address. Now, that means that it will take into consideration all connections to that server that may be part of other pools. Now, this one is more realistic if your servers will exist in different pools servicing different applications. So once again, this is a very similar example that we talked about before. But let's say that this is a server 10.10.1.10, and this is a server that exists in multiple pools, a web pool and a FTP pool. Now we say that there could be clients that's connecting into a web pool or to an FTP pool. So there could potentially be that 50 connections from the website is reaching this node here. And from the FTP side, 25 is reaching this server. So really, this server has a total of 75 connections. So that's why we may want to load balance based on the node so it can consider not just this number or this number by themselves, but the total number of connections to that server. Load balancing based on the pool member uses the IP and a particular port number that is running on that server. So that means it will take into consideration the total number of application connections only, like HTTP, to that server. So if this server here, which is a pool member, and we're load balancing based on the pool member, then that means that its decision will be only based on web connections to the server. So that means that this server could be part of other pools for FTP or some other custom application. So if we're load balancing based on the least number of connections or some ratio based, dynamic ratio based load balancing, then it may overwhelm the server, especially if it exists in different pools. But if you're load balancing based on the pool member, it's only looking at this number of connections and not the total connections that could exist to a server. So load balancing based on the node or the pool member will apply to these load balancing methods that we're going to talk about. And the first one is based on ratio load balancing. So in this static method, client requests are distributed more to a specific server or servers than other servers in a pool. So in this case, you would assign a ratio value or a weight to each server. And the server with the larger value will process more client requests compared to servers that have a smaller ratio value assigned. So for example, in this picture, we have 3 servers. Server 1 is assigned a ratio value of 10. Server 2 is assigned a ratio value of 5, and the last server will be assigned a ratio value of 1, which is the default. This means more client requests overall will be sent to server 1. The second most connections will go to server 2, and for server 3 and other servers that could be included, they will be load balanced evenly among them. So using ratio-based load balancing, this can be applied either to the node or to a pool member. Another load balancing method is least connections, and in this dynamic method, client requests are distributed to servers with the fewest number of connections. Now, if the connections are the same, then the connections will be load balanced using round robin among the servers. So this means that this method will consider the performance in terms of the connections for its load balancing decision. So for example, we have clients and they send a request to the big IP. So the big IP and its pool enable for least connections. We'll look at the total connections to each of these servers. So this one could be a total of 10, 12, and 8. So this has the least number of connections. Therefore, this client request will be sent to this server. So again, using least connections, we can apply this either based on the node or the pool member. Another method is the fastest method, and this is another dynamic method where client requests are distributed to servers that responds the fastest and doesn't have many outstanding application requests. Now this means that this method will consider the performance in terms of the application response time from each server. And of course, this method can be applied based on the node or the pool member itself. Another method is load balancing based on the ratio observed. And this is another dynamic method where client requests are distributed dynamically based on the following criteria. So servers with least connections are assigned a ratio value of 3 dynamically. And servers with more connections are assigned a smaller ratio value, assigned a ratio value of 2. And the big IP will determine this every single second. This means that this method will consider the performance in terms of the total number of connections. More connections, least connections for its load balancing decision. And this can be applied once more based on the node or based on the pool member. And the last method I want to talk about is load balancing based on ratio predictive, which is very similar to observed. So this is a dynamic method where client requests are distributed dynamically, but with different ratio values assigned. So servers with least number of connections are assigned a ratio value of 4, and servers with more connections are assigned a lower value, a number of 1. And once more, the big IP will determine this every second. So this method will consider the performance in terms of the connections for its load balancing decision and can be applied to either the node or the pool member within the pool itself.